Hello everyone, this will be vectors 2, day number, shouldn't be a 9. The way I've got it set up, it should be day number, I believe 5. Day number 5, intersection of a line and plane, angle between that line and plane, intersection and angle between two planes. So let's get started. Alright, so it's just some background knowledge you're going to need to, eventually, you won't use all of this, but at some point these are good identities to know trig-wise. But the main one we're going to use today, and actually it's not even written up here, but just to be able to kind of work with, is if we wanted to find this angle theta, cosine of the angle theta would equal the dot product of A and B over the magnitude of A times the magnitude of B. Okay, just being aware of that. Oops. Being aware of that is a majority of what you're going to work with today. Okay, so intersection of a line and a plane, you can see vector V here, and you can see our orange plane there. However, one of the most important pieces of a plane is Cartesian form, right? To have it in that form, we then know our normal vector. Now, if I could find angle beta, which is not the angle between the vector and the plane. That would be the angle between the vector and the plane, but I could find beta if I knew vector v and this normal vector. And at this point, we've got some shortcuts to where we can find the normal vector and the magnitude of it. So then we could do the inverse cosine, find beta. Beta will be some angle, right? Now theta and beta are related in this way. Theta plus beta should equal 90, right? Because the normal, as you can see here, is always perpendicular to the plane. Theta and beta should be 90, so if I take 90 minus beta, I should be able to then find theta. Alright, this slide is doesn't matter now because I already basically formulated what we're about to use, so skip it. Alright, so cosine of phi, I don't know why there's a phi there. Maybe, yeah, I know why there's a phi there. Because technically, phi would be this angle, but phi, that's Greek, is going to be equal to b. Those two are vertical angles. Okay, vertical angles. And therefore, theta equals 90 minus beta. So then we could find that acute angle between the vector and the plane. Okay, you guys, so the normal vector is like probably one of the most important vectors that you'll use with regards to planes. Alright, so here's a pretty cool problem. This is finding the point of intersection and the acute angle of the following line and plane. So if you just look at this immediately, you should be able to identify which one is the line and which one's the plane. Okay, take a moment, pause, and look at that. This right here is the vector equation of a line. Okay, I'm going to write it out in this form. I'm going to write out 1, 2, 0 plus lambda 3, 1, 1. And this plane, R, remember, is x, y, z. And 2, 4, negative 1 equals 28. Okay, so basically what I can do is I can lay this out in parametric form. This is a really fun problem for this reason. I can write this in parametric form. 1 plus 3 lambda. Y would equal 2 plus lambda. And z would equal lambda. Now this plane equation over here, all that I do is just multiply dot product. So I get 2x plus 4y minus z equals 28. That's just too easy. Okay, so if I want to know the point where they cross, right? The point where the line cuts through the plane, all I'm going to do is I'm going to plug in my x's for x, my y in for y, and my z in for z. So I'd get 2 times the quantity 1 plus 3 lambda plus 4 times the quantity 2 plus lambda minus lambda equals 28. Okay, and then I just distribute and simplify. So I get 6 lambda plus 2 plus 8 plus 4 lambda minus lambda 28. Okay, I see common like terms there, so that's 10. I see like terms here. So it looks like I get 9 lambda plus 10 equals 28. So if I solve that, I'm going to subtract 10, which is 18, divided by 9. I see lambda equals 2. So what does that tell me? That tells me my point of intersection. That tells me that x here, right, if I plug in a 2 for lambda, I'd get out a 7. If I plug a 2 in for lambda here, I'd get a 4. If I plug a 2 in here for lambda, I get a 2. So it looks like their point of intersection, where they cross, would be this point right here, 7, 4, 2. Pretty cool, right? We can take a line in a plane, we can figure out where they cross based on that lambda. All right. All just algebra from there. Now, if I want to find the angle between those two planes, what I need is I need 2 things, right? I need, oops, go back, here we go. I need to know a vector v and a normal n. Right, and then I got to be able to do some math there with the magnitudes and all that good stuff. Okay, so here's where the fun comes in. Here's our line, or our vector representation of our line. The only piece of this that I want to call v is the direction vector. So 3, 1, 1. So v is 3, 1, 1. Okay, let's look at our normal n. Okay, at this point you should know that your normal, if you look at the equation of your plane, your normal is just 2, 4, negative 1. The normal is so easy to find from the equation of a plane. 2, 4, negative 1. Okay, so we can find the numerator of this right here by doing the dot product. That'd be 6 plus 4 minus 1, which equals 9. Okay, now let's find the magnitude of each. The magnitude of v, if I look above here, would be square root of 11. And the magnitude of n, our normal vector, would be the square root of, whoops, would be the square root of 4 and 16, that's 21. So if we wanted to find the angle, and I unfortunately don't have my calculator with me, to find the angle, I would take the dot product of v and n, which was 9, and divide it by the square root of, what did I have, 11 and 21. Okay, take the inverse cosine of that, and you'll get some angle. Right? Now, that's not our angle, right? I almost forgot. Right? This is actually beta. This is beta. Right, so this is beta. So imagine, right, we got our plane, and we got our normal, poorly drawn. Right, we got our vector. This angle beta.
How are you?
We just found that. I'm good. I'm just recording, so you just made a video.
Oh, I did?
Yep, you just made it.
Heck yeah.
We just found angle beta.
Alright.
So whatever that is,
Whatever
right?
that
we're going to take 90 minus that angle, and that'll give us theta. Okay. So on this exit question here, I'm not going to do all the work here, but I just want to identify a couple things for you here. This would be your vector v. Your normal would be right here, 2, 1, 3. If you go through the process of finding beta first, I believe beta ends up being equaling 38.2 degrees. So 90 minus that gives you 51.8 for your theta. And the point of intersection that I get, I can't really fit it here. The point of intersection I get is -6, -4, and 5. So, and it looks like that answer is right there upside down. So, give that one a try. See if you can do that on your own. If you got questions, come ask me. I'd like to talk about a couple more topics, and then we'll be good for today. So, finding the equation of a line of intersection of two planes is pretty interesting. So, if you have the equation of both of the lines, right, what you want to do is you want to eliminate one variable on one side. So, for example, over here, maybe I'd eliminate y. Right? So, to eliminate y over here, I'd multiply this by -1, which would give me -x minus y minus 3z equals -3, right? And then I'm going to take these two, I'm going to add them together, so that'll give me x. The y's will go away. Oh, the z's will go away, and I get -3. Okay, so I get x equals -3. Okay, over here I'm gonna do. Let's do this. Let's get rid of the x's. Let's get rid of the x's. So I would want to multiply this first one by -2. So it'd be -2x minus 2y minus 2z equals -6. I'm going to add these two together. So if I add those together, the x's go away. I get -y plus z equals -6. So I get x equals -3. You might recognize this form. And I get y equals, oh boy, I got to manipulate that. So it'd be z plus 6. And that'd be the equation of the line where those two planes intersect. Now, if you visualize that, this would be our line, right? That'd be the equation of the line. So it looks like in our case, x is always -3, and y equals whatever z plus 6 equals. All right, now the last thing we're going to do here is we're going to find the angle between the two vectors. Okay. So if I find the angle between, or not the two vectors, the two planes. If I find the angle between the two planes, what I want to do is I want to find the normal of each plane. So the normal of the first and the normal of the second, and do the formula that we've been working with up until this point. So normal 1, let's take this vector here, would be each of the coefficients. 1, 1, 1. Normal 2, which is each of the coefficients here, would equal 2, 1, 3. The numerator of this formula would be the dot product of those, which would be 2 plus 1 plus 3, which is 6. The magnitude of vector normal 1 is going to be square root of 3. The magnitude of normal 2 is 4 plus 1 is 5, plus 9 is 14. So the cosine of theta equals 6 over the square root of 42. So by my calculations, I get that theta is approximately 22.2 degrees. Okay, now based on the orientation, that's the answer in this case. So the angle between those two planes is 22 degrees. But based on the orientation of your normal vectors, right? What's going to happen is you're either going to get an obtuse or an acute angle, right? So if I were to look at these planes from the side, if this were to be theta, right, that's going to be an acute angle. If you're to get a second theta, which is obtuse, these two angles are going to add to 180, which means they're supplementary. So the question might ask you for the acute theta, right? So if you get this obtuse theta, right, so reminder that theta 1 plus theta 2 equals 180. So if you get an obtuse theta, basically what you want to do is you want to take 180 and subtract that obtuse theta, and that'll give you your acute theta. Okay, so just something to be aware of. That's lesson 5. Should be good to go. So have a great day.